Spirally change na.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning.
Good morning. Good morning.
Good morning, sir.
Good morning. Good.
Good morning, sir.
Good morning, sir.
Good morning. Good morning.
Sir, in the test this Sunday, friction is not there, right? Okay,
So
sir.
then
Thank
which
you.
chapter will be there?
Laws of
Only
motion.
NLM.
Only Newton's laws. Okay.
Yes. And sir, in MT, there won't be any additional chapter except fiction, right? Like after fiction.
Sir, MT is our segregation test. Oh, thank God. Thank you, sir.
तो सर फ्रैक्शन का सेग्रीगेशन होगा नहीं क्या कभी?
नहीं होगा.
नहीं होगा, नहीं होगा.
सांस तो
You need to start with something important. People are yet joining. People are getting late and waiting for you.
Yes.
Sir, but the lecture ka time has already begun, so you start no. If they miss, they'll see the recording.
Yes, sir. Recording there.
Sir, yes, sincere, we came on time, sir. Now they're late. That's their fault, right?
Sir has a big.
Sir, anyways, everyone sees the recording three times, sir. There is no exception.
Yes, sir. I was seeing today morning only your lecture of 2 days ago has almost 250 views.
Yes, sir. Everyone sees,
Yes,
sees the
sir.
recording.
First of all, laws of motion in HCV, if for the questions for short answers part, so like there are no answers given, and I had few doubts. So can you discuss it before the test? Thank you.
Sir, they are very deep questions.
वाह, सबसे बदमाश बैच है ये.
Thank
Right. Thank you.
Thank you.
Tomorrow we have a lecture.
No, sir.
No, sir.
No, sir, we have
next
lecture
lecture
directly
is
on Friday.
Next on Friday.
Date on Friday.
Friday remind me. जो assignment 3 का कुछ balance doubts, HCV का doubts.
असाइनमेंट 3 का हो गया
Assignment
सर
हो गया.
हो गया सर यस सर
AVP sir ने कर दिए सारे.
Okay, perfect.
Or later classes may before MT, will you take revision of like the previous chapters?
See, I don't mind taking revision, but we are already slightly lagging behind. You will
Okay, so
start
then no
taking
problem.
revision next year.
Then no problem.
Before the MT, if we do revision, we'll be pulling back the syllabus. So let's not do
Okay,
it.
sir. Then no
Yes, sir.
problem.
Yesterday
Yeah.
only we got to know that Zenith batches have reached ahead.
Yeah.
then it's to
But
also
how is Zenith ahead?
Now listen. Newton's laws, you people can solve from your booklet, exercise 4, booklet, homework. This is for Newton's laws of motion without friction. Booklet, exercise 4. 1, 2, 3, 4, 5, 6, 7. 8, 10, 11, 12. Exercise 4. Exercise 3. Exercise 3. Match the column 1 and 2. Exercise 3. Match the column 1 and 2. Exercise 1 में every alternate problem is friction here. There's no point of giving homework from exercise 1 till I complete friction. Booklet say on Newton's laws. Please take down this homework.
Yes, sir.
Exercise 1, why I didn't give you is almost every alternate problem there is friction involved. So no point of giving. Exercise 1 I'll give it in one go.
सर अब असाइनमेंट 3 कब डिस्कस करोगे अभी? हाँ बाकी है।
अभी
Assignment 3 हो चुका है यार।
बाद में करो
हो
सर।
गया। कोई
हो
बोल
गया,
रहा
हो गया।
है?
हाँ
हाँ
हो
सर,
गया
हो
सर।
गया है।
तो फ्राइडे
Sir,
क्लास
exercise
में
2?
last
सर आप फ्राइडे कर लो ना प्लीज, आप
exercise
एक्सरसाइज
1,
कर दो।
listen to what is being told. Exercise 4 and 3 लिखा है, बस वही करो. Exercise 2 and 1 में every alternate problem friction is involved. There's no point of splitting it. Let me complete friction and give you that in one go. Make a note of this properly. Assignment 3 का अगर कुछ doubts है तो Friday lecture में याद दिलाना. Last half an hour I'll take that.
ओके सर।
इसमें 9th problem is missing because there is based on friction. 1 to 12 without 9.
Sir, today we are starting friction.
Yeah. And by default, HCV, Newton's laws. HCV put Newton's laws and friction separate.
यस
Yes, sir.
No. Friction is also one among these forces, tension and Newton. Tension and normal force. But there is a small difference. Friction is slightly intelligent when compared to tension and normal force.
Okay.
Friction is smart. Right? Hence, we have to be a bit alert while dealing with forces of friction. First point, what is the root cause for friction? It is interlocking between
Contact.
two surfaces. Interlocking between two surfaces. Interlocking between two surfaces. You mean to say because the surfaces have up and down, that is what is root cause for friction? Yes. Do me a favor, make it a smooth surface. Ironically, the figure shown to you is the microscopic view of a fine finished glass surface. Fine finished glass surface, microscopic view. Microscopic view of a smooth glass surface. Microscopic view of a smooth. That means if a smooth glass surface can look like this, normal surface, how rough it will be, you can understand. Right? This is the root cause for friction, firstly. And always friction opposes relative motion between two surfaces. Between two surfaces in contact. Relative motion between two surfaces in contact. Have a look at this. I'm pushing the duster ahead. friction is acting in backward direction.
Backward direction.
Yes, sir.
Yes.
Directs.
I'm pushing this way. Friction is acting in backward direction. Now listen carefully. I'm pulling the book ahead. Friction is acting in the forward direction. Why? What is the force which is pulling the duster ahead?
Friction.
Same duster, same surface. When I am pushing this way, friction is acting backwards because it wants to prevent relative motion between the two surfaces. Same duster, same book. When I am pulling the book ahead, friction is acting in the forward direction to make sure that this block is at rest with respect to the surface. Friction's prima facie requirement is to make sure that this surface is at rest with respect to the book.
Okay, sir.
So in this situation, friction is acting backwards. In this situation, friction is acting forwards. It is friction which is making the duster move. Without friction, duster will not move. There is no horizontal force on the duster.
Yes.
But duster is moving with respect to ground. That means it is friction which is pulling it ahead.
Yes, sir.
So friction's first
Yes.
quality that we should admire is loyalty to the surface on which it acts.
Yes, sir.
Second, it's smart. It will change its directions depending on the convenience. One instance it will act backward, one instance it will act forward, whichever is required to prevent slipping between the two. There is a third quality which we will admire in friction. Friction can adjust its value as well. First experimental observation that people found with friction is they found friction to be directly proportional to the normal force. Friction to be directly proportional to the normal force.
Yes.
Then they removed the proportionality and they put friction is equal to mu into n,
Mu.
where mu is called coefficient of friction. We shall define this. First take this down till here.
So, but then how does the speed like if you move the book quicker, then the duster will slip, right?
We'll deal with that. Don't worry, we'll come to that. Probably in today's classes.
And so had it been an extremely smooth surface, so that duster will fall off from the opposite side, right? When you move
The
the book.
duster will remain there, the book will go.
Yeah.
Sir,
That
what
is
if you
because of no
move-
friction.
There is no friction, duster
Yeah.
will remain there, book will go ahead.
Perfect.
Sir, what if you move the book upwards?
No.
What do you want next? उसके बाद question तो बोलो. I move the book upwards. Now what do you want to calculate?
And sir, in which direction will the friction have?
0.
Okay.
Sir, can you repeat the primary function of friction?
What function?
Primary, you said it opposes some, means its primary function is to make the object to rest.
Friction opposes relative motion between two surfaces in contact. This is the primary function of friction.
Done, sir.
So just a second.
1 second. Now, how did you define coefficient of friction? Frictional force, it is the ratio of frictional force to normal force. Coefficient of friction is defined as the ratio of frictional force to the normal force. Frictional force acting to the normal force. So it will have no units. It will have no units. Why will it not have any unit? It is the
Ratio of
ratio
two forces.
physical quantities. For all practical reasons, for all practical purposes, mu is less than 1, greater than 0. Theoretically, I can have a mu greater than 1. Fevicol, had देखा है फेविकॉल का आपने?
हाँ सर देखा है।
Mu can be greater than 1.
sir.
Theoretically, mu can be greater than 1. All over polished surfaces. Over polished surfaces. Mu will be greater than 1. For all practical problems, mu will be less than 1, greater than 0. This will depend on the nature of the two surfaces. Over polished, can you give me an example? Take two glass plates.
Yes.
Place them one over the other, you can slide. Put a few drops of water. Put a few drops of water and then slide.
Yes sir.
Becomes difficult.
Yes, sir.
If you people observe at home, after the utensils are clean, you dry them and then you stack them.
Yes, sir.
Yes
Stack
sir.
them when they are wet. It becomes an adhesive.
Yes, sir.
You stack them when they are wet. It becomes an adhesive.
Yes sir.
Right? So theoretically, I can have a mu greater than 1, but for all practical reasons, we will be using mu between 0 to 1 in general. Fevicol, mu will become greater than 1. So in this chapter, we will not be dealing with Fevicol. We will deal with that in the chapter surface tension. So right now, we'll be dealing with mu less than 1, greater than 0. Your HSC textbook preferred to keep both these in one chapter called forces. One second. Mu can be equal to 1 as well. Greater than 1 जब हो सकता है, 1 भी हो सकता है. No big deal in it.
So is there any particular reason for this demarcation, like for practical purposes, this is belonging to 0 to
Till
1?
when it is moving, mu will be less than 1. Till when one body can move on the other body, mu will be less than 1. Once you make sure that you cannot make it move, mu becomes greater than 1.
Sir, and if mu is equal to 0, then a person won't be able to walk on that surface, right? Because then there will be no friction.
Frictionless, naturally. I'll come to that.
So if mu is equal to 1, then the normal force will become equal to the frictional force, right?
Magnitude wise, they'll become equal. Directions, they will not be equal. This is magnitude, both.
Yes.
Yes, sir.
Sir, how are frictional force and normal force related to each other?
Wait, switch off the mics for some time. Let me teach the concept first. Listen. This mu n is called limiting friction. Mu n friction. We will call this limiting value of friction. limiting value of friction. That means the maximum value I can have implies maximum value that you can have. You told me friction will not only adjust its direction, but also magnitude.
Value.
So friction can be less than or equal to mu n, greater than or equal to 0. Limiting value of friction is mu n. What do you mean by this limiting value? Could you make us visualize this? But dhyan se speed. This is some block with some mu value. Limiting value of friction mu n turned out to be 10 Newton. I am taking arbitrary numbers to explain this. How much is limiting value of friction?
So 10.
10
Newton.
Now, I decided to apply 2 Newton of an external force on it. Will the block move?
No.
No, sir.
No. Then how much is the frictional force acting here?
10 Newton.
2
Here
Newtons.
10 Newton bola, he fell for the trap. Implies I am pushing the block in that direction, block is moving backwards. Hota hai kabhi aisa?
नहीं
sir.
So first of all, I'll make the question more simple. Suppose I didn't apply any force. What is the frictional force acting on?
0.
Table is a table. Table aisa hai. I didn't apply any horizontal force. Table is not moving, right? It's at rest. So frictional
Yes, sir.
force is 0. Now I applied 2 Newton. Frictional force is how much?
2 Newton.
2
Newton.
2 Newton. Now I applied 5 Newton. Frictional force is how much?
5
Newton.
I applied 10 Newton. Frictional force is how much?
10
Newton.
Newtons.
Now the story changes. I applied 12 Newton.
10
10
Newton.
Newton.
10 Newtons.
Not exceed 10 Newton. That is the limiting value of friction.
Sir, what will happen in this case?
It will accelerate to the right with a force equal to 12 minus 10 divided by m. When I am applying 12 Newton, the limiting friction 10 Newton will remain same. And when I apply 10 Newton, acceleration is 12 minus 10 divided by m. So if I want the body to move and accelerate, I should apply a net external unbalanced force greater than
Frictional force.
the limiting value of
Limiting
friction.
value.
Greater than
The limiting value of frictional force.
Until the force applied is not more than the limiting value, the body won't move.
perfect.
Okay, sir.
So, but
Now,
still the frictional force
As
is.
though all of you keep your mics off till I complete the concept. It will appear as though it is a very straight head. It's not. I'll explain, take it down till here.
So I have a doubt.
Bolo.
So even after, like, if you've applied 12 Newton and the body starts accelerating, friction will still act on it and to bring it to rest, right?
Well, how will it bring it to rest? You are applying 12 Newton. Maximum friction I can have is 10 Newton. Friction will keep acting continuously. Body will be accelerating continuously with 2 by m meter per second.
Okay. So you're continuously applying 12 Newton. It's not like you've applied once and you're leaving it. You're continuously
Leave it,
applying.
obviously it will come to rest.
Sir, over here when friction is lesser than the limiting value, it will not move, right?
It will not move. I rather put it the other way. If the block is at rest, frictional force will be equal to the external force applied. If the block is at rest, frictional force will be equal to the external force applied. If external force is 0, friction is 0. So friction is a self-adjusting force. What force is it? Self-adjusting force. It's not dumb like tension and normal force. It's smart. It can adjust its value, both magnitude and direction, and it is very loyal to the surface on which it acts. It will make every possible attempt to make sure that the two surfaces are at rest with respect to each other.
Sir,
Hmm.
sir, we know that friction is dependent on the normal force, right? So your whatever
And the
external,
nature of the surface.
yes,
Friction
sir,
is dependent on the normal force and the
and the
nature of the surface.
yes, sir, sir. So it is not dependent on the external force which is acting, right? Like we'll have some predetermined value of friction
It
which is
will
going to have.
adjust its value. यार लिखा है मैंने तू रिवर्स पूछ रहे हो एक स्टेटमेंट पढ़ो and you're asking me friction is not dependent on the external force. It is dependent on the external force, equal to, not even dependent, it is equal to the external force if the body is at rest. Once the body starts moving, it's not dependent on the external.
Okay, sir.
Sir, done.
Sir, this may be a silly doubt, but when Newton was giving his laws, he did not consider friction, right?
Yes.
So what did he say?
He has considered friction.
Okay, sir.
Now listen. In mu, we have got mu s and mu p. Coefficient of static friction. Static friction. This is coefficient of kinetic friction. Mu k will be greater than mu s. Sorry, mu s is greater than mu k always. Initially, when the body is at rest, pulling it needs slightly greater force.
Yes.
Once the body starts moving, the science behind this is like this. When the interlocking is there, now this is resting inside this group.
Yes, sir.
Once you start moving it, the peaks will start getting slightly chipped off. Once you start moving it, the frictional force value will decrease. Initially, it is comfortably resting in the groove. So to pull it out of the groove, you need to apply slightly greater force. So mu s will be slightly greater than mu k, slightly. Generally, the difference will come in the second decimal. For example, mu s is 0.44. Mu k will be 0.40. Generally, for problem's sake, they may play with the value. Generally, mu s and mu k may the difference comes in the second decimal place. So in many problems, they will not give you both these values separate. They'll give you mu is 0.4.
Yes,
They give you mu is 0.4. So you can normally treat the problem as though mu is 0.4. But suppose they give you mu s and mu k separately like this. Consider this mass to be 10 kg. How much minimum force do I apply for the block to move? For the block to move, how much force do I need to apply? Normal force is equal to 10 g. Frictional force will be mu into N. No, it is at rest. How much force should I apply? F minimum will be equal to mu s into N, static friction. I will have to apply this minimum force to make the block move. How much is mu s? 0.44. How much is the normal force? 10 into G. This will be 44 Newton I have to apply for the block to just start moving. Now, once it starts moving, for it to move with uniform speed, how much force should I apply? For the block
Equal
to
to the
move with
mu into
uniform velocity, force to be applied will be mu k into n, 0.4 into 10 into 10. This will be 40 Newton of a force.
Yes, sir.
For it to move, I had to apply 44 Newton. If I continue to apply 44 Newton, block will be accelerated.
Yes.
Once it started moving, for it to move with uniform velocity, I have to apply slightly lesser force. Why? Because now it raised from the groove and it's slightly chipping off the upper edges.
Yes,
So
sir.
mu will slightly decrease. Mu s, mu k. Coefficient of static friction, coefficient of kinetic friction.
So I had a little silly doubt. So the interlockings are tending to infinity, right, between two surfaces. So, but still, if you keep rubbing it, will there be a point when the friction decreases?
Yes, that is called polishing. When you are rubbing it, you are firstly decreasing the size of the peak.
Yes, sir.
But when you further rub it, over polished surfaces will become so smooth that the molecules will start coming in contact with each other.
Oh.
Once two molecules come in contact with each other, there are two forces called adhesive and cohesive forces which come into picture.
Yes.
Their mu will become greater than 1. Adhesive and cohesive we will deal with in the chapter surface tension. Adhesive word Sehi, the word adhesive came into picture.
So if
What we
same,
use is gum,
Okay.
cellotape, Fevicol, all these are called adhesives. The word is derived from this.
so if same objects have like glass and glass have a very contact forces that is cohesive, and if two different objects are being sticked due to that force, it's
Force
adhesive.
between similar molecules is cohesion.
Yes, sir. Cohesive.
Dissimilar molecules is adhesion.
So these two are only attractive forces.
Attractive, adhesion and cohesion.
Yes.
They're only attractive. They can never be repulsive.
Done, sir.
Sir, wait, sir.
So the difference that we get, the subtraction of the minimum force and then the force required for uniform velocity, does it have any significance, or it's just that like the force has been reduced?
The force has been reduced. It depends on the value here.
Okay.
So
So if they don't give us different values of static coefficient of static friction and kinetic friction.
I didn't full get you. Say that again. Say that again.
So can you hear me now?
Yeah.
So if they don't give different values for static friction and kinetic friction, then will it be same for uniform velocity and we just move the block, the frictional force, the
I'm
force
unable to
required?
clear to your doubt completely, but I am assuming this is what you want. If there is no difference between the two, only one value is given. So consider that only to be the static as well as kinetic. So the force you need to apply for it to stay at rest and uniform velocity will be the same.
Sir, I have a doubt that whether this kinetic friction is considered negligible while taking this kind of questions of finding the force exerted.
Negligible कहाँ भाई साहब 0.4 है ये 40 न्यूटन negligible कर लोगे.
तो मतलब कि वो मतलब ऐसा जब भी हम लोग ये फाइनल फोर्स निकालते हैं ना, फोर्स एक्सर्टेड, जिससे वो आगे मूव होने चलता है, तो तभी ऐसा कुछ ऐसा नेग्लिजिबल नहीं करते, ऐसा 4 न्यूटन का जो है चेंज, और डू वी कंसीडर इट?
उमेर क्या बोल रहे हो यार? This is the force I need to apply to just put the block moving. If I continue to apply that force, the body will be accelerating at 4 divided by 10 meter per second.
Yes, sir.
Right? If you want to move with uniform velocity, you will have to decrease the value to 40. Negligible approximations इन सब बारे में मैंने कुछ बोला ही नहीं. अब नए-नए फंडे कॉन्सेप्ट्स मत लाया करो बीच.
Okay, sir. Understood, sir.
Now, if I were to draw this graph, how do you draw this graph? This is the force applied. This is the frictional force. I showed you an example. I applied 0 Newton. What is the frictional force?
0 Newton.
0 Newton. 2 Newton. What was the frictional force?
2 Newton.
5 Newton frictional force was?
5
Newton.
Newton.
Be a straight line with an angle of 45 degree.
Sir, it will depend upon the length.
Constant. Thereafter, it will remain constant. Once it reaches mu n, friction will remain constant. आप external force कितना भी ले लो, external force आप कितना भी ले लो, once it reaches mu n, friction will remain constant. एक छोटा सा correction करेंगे, ढंग से देख लो आप. This is mu s. This is mu s into n. This will be mu k into n. This is mu s into n. This will be mu k into n. You will have to slightly go ahead and decrease the value for it. And once the body starts moving, the frictional force acting is not mu s. Once the body starts moving, frictional force acting is not mu s into n. It will be
mu k.
Hence, it will slightly decrease and thereafter it remains constant. This thing tells us that there is a small difference between mu s into n and mu k into n. Coefficient of static friction into normal force, coefficient of kinetic friction into normal force.
Yes.
Is that clear?
Yes, sir.
सर न्यू एस से न्यू के जब हो रहा था, मतलब न्यू एस एन से न्यू के एन हो रहा था, तब सर वो मतलब ऐसा किंक होता है या वो ग्राफ वहां पे कंटिन्यूअस होता है या वहां पे एसिम्प्टोट होता है?
कंटिन्यूअस ही होता है. It is continuous. The transition is smooth.
Okay. It's just so we'll have to apply less effort, like less force to pull it, right?
Right. Slightly
transition.
effort to make it move with uniform.
Yeah.
Yes, sir.
All of you write a no. One of the student typed a doubt. I'm answering that doubt. Write a no. Friction is independent of the area of contact. Friction is independent of the area of contact. Surface area of contact, rather, much more appropriate. Friction is independent of the surface area of contact. Friction is independent. This is a fundamental property. It depends only on mu and normal force. I am standing this way. You apply some force will make me move. Right? I stand with pressure on my toes. I stand with pressure on my heels. I stand on my toes. The force or frictional force will be the same. You will understand why at a later stage, but make a note of it. Friction is independent of the area of contact. Then brakes, why do they give huge paddles here? To decrease wear and tear, not to increase friction. Size of the brake, the breadth of the brake doesn't matter. Their wear and tear of that rubber is more dangerous, hence they give you greater area. Not that friction is working. Friction works only on the normal force and mu.
Sir, in 7th grade, I was there in PACE, so the faculty didn't tell us about this topic while teaching friction. And the question was asked in the exam about that it depends upon the surface area or not. So me and my friend were sitting on a sliding, and we both slided. We both are of different structures and surface area, but we both slided with the same friction and same time. So we discovered that friction doesn't depend upon that.
In
And we
fact,
marked
I
the
will tell
correct
you
answer in the
easier
exam.
way. There are experiments demonstrated on YouTube based on this. Different areas, same masses, same normal forces sliding down. YouTube search kiya hota tab to you don't need to slide down.
Sir.
Sir,
Actually.
but they say that at faster speeds, bigger brakes will be better.
Bigger brakes for wear and tear. Value of the normal force.
Sir,
So,
then why do
it has
people
no
use
relation
wheels?
to actually bringing
Hey,
it to
all
rest.
switch off your mics. Let me teach first. You people express your ideas even before I teach. Now, have a look at this. Pay attention. This angle is theta. This will be mg sin theta. This will be normal force. This will be mg cos theta. Frictional force will be acting up. Friction will be acting up. How do you calculate the limiting value? Body on an inclined plane. Body on an inclined plane. Body accelerating down an inclined plane. Now, friction, I have told you in the problem that the body is accelerating. That means frictional force will be mu n. Value of normal force here is not mg. How much is the value of normal?
mg cos theta.
mg cos theta. So what will be the acceleration of the body sliding down an inclined plane?
mg sin theta
mg sin theta minus mg cos mu and g cos theta upon m.
Divided by n. G sin theta minus mu g cos theta is acceleration of a body moving down an inclined plane. If length of the inclined plane is given half a t squared, I can write half g sin theta minus mu g cos theta into t squared. Derivation as picked up from your HSC textbook. Acceleration of a body sliding down an inclined plane. Acceleration, ACC means acceleration of a body sliding down an inclined
So here initially.
Trouble starts यार पढ़ाने तो दो ना यार बहुत interrupt करते हो आप लोग. Forcibly I'll put all mics on mute if you people interrupt this.
Sorry, sir, sorry.
Now listen. Now our problem starts from here. First to take this down.
Sir, we have get to know that in the newspaper it was there that HSC board is going to start from 1st November.
मैं क्या करूं? रोक दूं उसे?
Yes, sir.
Yes, sir.
बाबा तौसीफ का था.
क्या हुआ सर?
नहीं विनायक
सर वो विनायक था सर.
विनायक था सर ये.
Sir, you know there is a sticker of तो मैं क्या करूँ as well.
Yes, sir.
Things which are not in my hand. What do I do? There is nothing.
सर वही तो आप बैठ के फ्रिक्शन पढ़ा रहे हो. HSC कब शुरू हो रहा है आपको बोर्ड में?
अरे भाई ये आपके HSC सिलेबस में है तो है, बताऊंगा ना यार.
अच्छा
अरे
सर.
नहीं सर, आई एम सेइंग कि आप इधर फ्रिक्शन पढ़ा रहे हो और वो
अरे
आपको
ठीक है,
बोर्ड में
समझ गए.
HSC कब शुरू होगा?
Okay. ऋषभ राम जी.
Yes, sir.
तेरा डीपी बड़ा अजीब लग रहा है यार, डर लगता है ये डीपी देखकर.
Sir, it's a character I really like.
Is it?
Yes, sir.
Sir, I had a doubt, sir. Can I ask? Sir, earlier you told us that friction is independent of surface area of contact. Sir, but when we were in school, we were taught that ball bearings are used because they reduce the friction due to
Wear and tear.
So
Ball bearings are used to decrease not the area of contact. They are converting sliding friction to rolling.
Rolling friction.
Yes, sir.
We are yet to come to rolling friction. It will take a lot of time till then.
Okay, sir. Okay, sir. So rolling friction is like less.
Much lesser than
क्योंकि
sliding.
सर रोलिंग फ्रिक्शन में सिर्फ एक पॉइंट कांटेक्ट में होता है ना, तो वो तो when he was worthless.
सर ये लास्ट इक्वेशन एक बार समझा सकते हैं क्या? What is that? L
S equal to half AT square. S is equal to UT plus half AT square. 3 बार repeat.
Yes sir, yes.
Yes sir नहीं, yes sir 3 बार बोल रहे हो. S equal to UT plus half AT square 3 बार.
S equal to UT plus half AT square. S equal to UT plus half AT square. S equal to UT plus half AT square.
Wonderful.
Done, sir.
So one second.
Yes, sir.
Sir, I have a doubt.
Yes, sir.
Sir, if friction is independent of surface area of contact, then sir, what about those kind of questions where this in icy surfaces be where this kind of boots with the spikes, so because it causes more of the friction or kind of things.
Mu. When you have spikes, what you are changing is mu. Sharper the edge, greater the interlocking.
Yes, sir.
Okay, sir. Okay, sir. Understood. Sir. Thank you, sir.
अब थोड़ा ध्यान से सुनिए. I'll take a numerical example to explain this. Mg sin theta is say 5 Newton. Sorry, 10 Newton. And mu n turns out to be 5 Newton. Will the body accelerate down the inclined plane?
Yes,
or no?
Yes, sir. Yes, sir.
Yes.
Now this is in reading. For the body to remain at rest, how much external force do I have to apply?
5 Newton.
9.
Wonderful. Suppose I increase this to 8 Newton, what will happen?
Will accelerate words.
Accelerate up.
Friction will start acting in opposite Friction starts direction. acting
Friction
starts
starts
acting in the opposite direction.
आलू ले लो.
The friction in opposite direction of 3 Newton.
Will decrease its value to 2 Newton
Yes,
from
sir.
5 Newton to keep the block at rest. Friction prima facie requirement is to keep the block at rest. It doesn't have an ego problem. That is the best part of friction. It will decrease its value from 5 to 2 Newton. Now, I told you friction can take any value between 0 to mu n. Mu n is the maximum value. That is the limiting value of friction. It decreases it to 2 Newton. It cannot have more than 5 Newton because mu n is 5 Newton. But it can decrease its value. Now, don't you think 8 plus 2 will be equal to 10 and it will keep the block at rest?
Yes.
Yes. Now you understand why friction is smart?
Yes, sir.
So many qualities you need to learn from friction. 1, it's smart. 2, loyalty to the surface on which it acts. Right? 3, it doesn't have any ego problem in decreasing its value. अच्छा force है कि नहीं?
हाँ, sir.
Yes, sir.
Yes, sir.
10 Newton अगर कर दिया तो what will happen to the block?
Zero.
No
Sir, no
friction.
friction will happen.
So,
नहीं मतलब cancel out हो
block
रहा है
at
तो friction.
rest,
Yes.
right?
Yes.
Now observe this. Here I'm running short of space. I'll redraw the diagram for your convenience. mg sin theta will be 10 Newton, right? Mu n is 5 Newton. Now continuation of that I'm writing here. Now listen to what happens. I applied it 12 Newton of a force.
So friction opposite direction.
Friction, don't tell me block will start moving upwards. Friction
2
will
Newton,
Will
sir.
manage it to
its
2
value
Newton.
and
Direction.
will make
Yes.
itself 2 Newton. Friction will change its direction and make itself 2 Newton to keep the block at rest. I make it 15 Newton. Friction
5
will
Newton.
5
Newton.
Newton. 5 Newton. Beyond 5 Newton, friction is helpless.
Yes.
Its limiting value you are given is 5 Newton.
Yes, sir.
Yes.
So this is the minimum force I have to apply to keep the block at rest. This is the maximum force, external force I apply to keep the block at rest. F external minimum to keep the block at rest. Beauty in the problem is when I am applying minimum force, friction is acting upwards with its maximum value. When I am applying maximum force, friction is acting downwards with its maximum value. Now you understand how friction acts. It's not like tension and normal force that I can tell you a fundamental rule. Friction always acts in this direction. Depending on the external force, friction will not only adjust its value, but also direction. Its prima facie requirement is to keep the block at rest with respect to the surface.
Right.
Is this point clear to all?
Yes.
Yes, sir. Clear.
Yes, sir.
Take down this numerical example. I will deal with symbols.
So the body is at rest for external force ranging from 5 Newton to 15 Newton, right?
Wonderful. In this example.
सर रुको. Done, sir.
First of all, we define angle of contact. Angle of contact, also referred to as contact angle. Contact angle. What is angle of contact? If this is normal force, this is mg, and this is frictional force. Generally, till now we were using this word normal force and contact force without much of a discretion. For me, normal force and contact force till now were the same.
Yes.
Not anymore from here. This is called normal force. Normal force. Resultant of friction and normal force is contact force. F square plus n square. R is root over of f square plus n square. This will be called contact force. Right? And this angle phi, tan phi is friction by normal force. Tan phi is friction by normal force. This is called angle of contact. Angle of contact. Tan phi is called angle of contact. Hereafter, contact force का मतलब resultant of friction and normal force. When friction was zero, contact force and normal force were the same.
Yes,
Till
sir.
now we used to use that with not much of discretion. Sometimes normal force, normal contact force, so on and so forth. But hereafter, once I've got friction, this is contact force and this is normal force. But the tricky catch in the problem is friction, you cannot always give me one particular value. It will depend on the problem.
Yes.
Yes.
Right? Suppose I am applying an external force. Right? There are two cases. Case one, F external is lesser than mu n. The external force applied is lesser than mu n. That means the block is not
Moving.
The block is not moving. Frictional force is equal to the external force. Do you agree with that?
Yes.
Tan phi b. Tan phi will be F external by normal force. Tan phi is technically friction by normal force, but here the magnitude of the friction will be equal to the magnitude of the external force.
Yes.
Right? What is case 2? What if F external is greater than mu n? Now the block is sliding.
Yes.
Block is sliding. When the block is sliding, what will tan phi be equal to? Mu n?
Mu n by n.
By n. This will be mu. So tan phi will be equal to mu when the block is sliding. When the block is not sliding, tan phi will be lesser than mu, because I'm damn sure when the block is not sliding, friction is less than mu n.
Yes.
Friction is less than mu n. Friction is less than mu n, tan phi will be lesser than mu. So the maximum value of contact angle will be mu. I can have a contact angle anywhere between 0 to mu.
Okay.
Tan phi rather. Tan phi can be anywhere between 0 to mu. Three important things summarized on the board. Difference between contact force and normal force. Second, angle of contact. Third, angle of contact is frictional force by normal force, but value of friction could be either external force or mu n. If the body is at rest, friction's value is equal to the external force. Body is moving, friction's value will be equal to mu n. All 3 points are important. Make a note of it.
So, but isn't friction anyway equal to nu n?
Only when it is sliding. When it is not sliding, this friction is equal to the external force of sliding. It will be less than mu n.
Okay.
Sir, can you again explain the case 2?
Case
When
two,
if external is
external is greater than mu n, the body is sliding. When the body is
Yes,
sliding,
sir.
what will be the frictional force? Mu n.
mu n, yes, sir.
Once the body is sliding, the frictional force is the limiting value mu n. Mu n divided by n. Tan phi will be mu.
Yes, sir. Understood.
Normal contact force. See, from here onwards, normal contact force does not make sense. This is normal force, this is contact force. When there is no friction, I use those words without much of discretion, it's okay. Normal force once, contact force once, so on and so forth.
Sir, can we say that for the body to be at rest, friction and F external have to be equal because they're in opposite directions?
Naturally.
Okay, sir.
Contact force is the resultant of friction and normal force. Remember that. Contact force is the resultant of friction and normal. Can I rub the board?
Yes, sir.
So 2 minutes.
Just case 2 only. They're done.
Now, this is called angle of repose. Angle of repose. What is angle of repose? That angle of the inclined plane at which the body just starts sliding. Mg sin theta. Friction is mu n, which will be equal to mu mg cos theta. What is defined as angle of repose? That angle of the incline. That angle of incline at which that angle of incline at which body just starts sliding. When will it just start sliding? When mg sin theta is greater than or equal to mu mg cos theta.
Yes, sir.
Yes.
Normal
Yes,
force
sir.
is equal to mg cos theta because it is not accelerating in the direction. So
Yes, sir.
tan theta is equal to mu is the angle at which the body will just start sliding, limiting value. Technically, tan theta should be greater than mu. For the body to slide, for the body to slide, tan theta should be greater than mu. It is a mere coincidence that angle of contact in case 2 and here tan, you are getting the same value mu. It is no way related. It is a mere coincidence that both of them are the same. There is another point where it will coincide.
Sir, technically this mu is mu s, right?
Mg sin theta friction. F minimum and maximum to keep the block at rest. To keep the block at rest. One second, just wait, I'll come back in a second. Now listen. We want to find out the maximum and minimum force required to keep the block at rest. When it is at minimum, friction will be mu n. This is mg cos theta. When I am applying the minimum force, friction is upwards. How will you write the equation? F minimum plus mu n is equal to mg sin theta. Block had a tendency to move downwards, so I have to apply F minimum upwards. F minimum will be mg sin theta minus mu mg cos theta. Now, on the contrary, when I am speaking about F maximum, block will have a tendency to move upwards, mg sin theta. So friction will act downwards, mu n.
Downward.
This is normal force, this is mg cos theta. So what will F maximum be? F maximum is mg sin theta plus mu mg cos theta. This is F minimum is mg sin theta minus mu mg cos theta. F maximum is mg sin theta plus mu mg cos theta. This is the minimum force, maximum force to be applied to keep the block at rest. We explained this using numerical examples.
So, so but in the last what you wrote, so you had said that when a body is at rest, the frictional force is equal to the F minimum. External force, sorry. Frictional force is equal to the external force.
Net external force. It's the same here. Net external force is F maximum minus mg sin theta.
Okay, net external force, okay.
Net external force. So external force F and mg sin theta. Both put together.
So it will be
Sir,
equal
here
only,
it is
right?
on.
Because it is the at rest. So it will be equal.
Yeah.
Done, sir.
Done, sir.
Yes, sir.
Find the frictional force acting on the block. Find frictional force acting on the block.
So what is the angle of the incline?
37 degrees.
Okay.
You people want the value of sin 37 cos 37?
No, sir.
No, sir.
No,
We
sir.
know,
No,
sir.
no.
3 by 5, 4 by 5.
3 by 5 and cos 37 4.
और कुछ चाहिए?
नहीं सर.
एक कप
सर याद
Somebody wants the value of G, take it as 10 meter per second square.
Yes, sir.
Firstly, you will calculate mg sin theta, mu mg cos theta. Mu mg cos theta is
Yes.
turning out to be how much? Mu mg cos theta.
53.6 Newton.
10 into 4 by 5. How much is this?
53.6.
Yes, sir, 53.6.
No, listen. This frictional force is 53.6 Newton. What is mg sin theta value?
60 Newton.
60 Newton. 60 Newton. So block is moving.
Moving.
Block is moving. What is the frictional force acting on it?
53.6 Newton.
53.6.
Is it clear?
Yes, sir.
Yes, sir. Now, suppose this value turned out to be lesser than mu mg cos theta. What will be the frictional force acting on it?
The amount of force which was.
mg sin theta.
mg sin theta will be the frictional force
Yes,
acting on
sir.
it.
Yes, sir.
Yes.
T turned out to be lesser than 53.6. Then the frictional force acting on the block would have been
Equal to him.
equal
To
to
mg sin theta.
So please can you repeat just what you said? I got disconnected.
if mg sin theta is lesser than mu mg cos theta. Then what happens? Block is at rest.
Yes.
Block is at
Yes.
rest. If
Yes,
the block
yes.
is at rest, then what will be the frictional force acting on it?
Equal to
mg sin
The external force. If block is at rest, mg sin theta should be equal to the friction. Block is at rest. This will be mg sin theta. This will be friction. Because the block is sliding, friction in this case was mu m. If not, friction will be equal to mg sin theta.
Sir, so 53.6 is the limiting value of friction?
Limiting value of friction.
Okay, sir.
And 60 Newton is greater than this. So the block is sliding. If the block is sliding, frictional force acting on it will be the limiting value.
so the maximum value of friction is 53.6 Newton, right? Which is the
Right.
limiting value.
Right.
Done, sir.
Yes, sir.
Done, sir.
Pulling a body is always easier than pushing a body. Pulling is easier than pushing. Obviously, I'll be speaking about the same angle. I am pulling with a force of F. This is theta. This will be normal force plus F cos theta. Sorry, F sin theta. This will be F cos theta. Tell me how much force I should apply so that the block just moves. F cos theta should be greater than or equal to mu.
Yes, sir.
F cos theta is greater than or equal to mu. What is the value of n?
mg minus
G
f
cos
minus f sin theta.
mg minus f sin mg n plus f sin theta is equal to mg.
Yes, sir.
mg minus f sin
Yes,
theta.
sir. Yes.
F into cos theta minus mu sin theta is greater than or equal to mu mg. F is greater than or equal to mu mg by cos theta minus mu sin. This is the force I have to apply to pull the body. To push at the same angle, this will be mg plus f sin theta. This is f cos theta. This is the normal force. This will be the frictional force mu n. Now here you are pulling.
Yes.
Here you are pushing. F cos theta is greater than mu n. F cos theta is greater than or equal to mu. What will be the value of n?
mg plus f sin theta.
mg plus f sin theta. F into cos theta minus mu sin theta is greater than or equal to mu mg. Am I committing a mistake here? It
In
was
the first one, it should be plus.
So it should be plus.
When I
Yes.
brought this to the left, it will be
Yes,
plus.
sir.
F should be greater than or equal to mu mg by cos theta minus mu sin theta. Which force do you think is lesser?
Pulling.
Sir, pulling.
Pulling force.
One is less.
In general, though the example that I give perfectly doesn't suit this, but if you people observe in 99% of the cases, the luggage that you pull will always be given a system where you pull your luggage. Your
Yes,
handbags, your luggage, you will always be pulling. Though there are rollers, the friction there is rolling friction, system is slightly different, but you will never push that. Right?
Yes,
You will be
sir.
pulling your luggage. Then wheelchair, why do you push? Why don't you pull the wheelchair? For a wheelchair, comfort of the patient is taken into consideration, not your comfort. Patient पीछे क्या हाल में है पता नहीं, you are pulling and taking him away doesn't work. And actually pushing the patient in the wheelchair is not easy. Hence they bend. They lift the front part and then they push the wheelchair. If you people have observed.
Yes.
Pushing is not easy, but yet when it comes to a wheelchair, it is the patient's comfort which is important. Hence, they always make sure that pushing is done in a wheelchair. When you go to a departmental store, you keep putting all the commodities that you buy into a crate which you will be pushing. Pushing is not comfortable there, yet you push there
Yes, sir.
because you need to see the items that you are putting. You cannot keep throwing the items behind.
Yes.
Yes, sir.
For practical reasons, there you will be pushing. But in general, pulling is always easier than
Yes, sir.
Pushing.
Pushing.
So n is equal to mg, right?
N is not equal to mg. N plus f sine theta is equal to mg. Body is not moving vertically. So n is mg minus f sine theta. In this case, n is equal to mg plus f sine.
Okay.
So that's why we push the car when it doesn't start, not pull it.
Pulling is easier. You don't have a rope there.
बचा दिया.
Pulling is easier. अगर rope है तो pulling would have been easier. मगर एक danger भी है. Immediately when the car starts, it will come onto you when you are pulling.
Yes.
हाँ सर
Sir,
चढ़
by
जाएगी.
that logic, तो when you tow the car, you pull it only, na? Sir, when you tow a car, you are pulling the car, you are not pushing the car
When
while
you
towing.
tow a car, you are actually pulling the car. They will lift the upper part and pull it and take it. Towing का बहुत experience है बंदे को.
बहुत गाड़ी आउट हुई.
Towing का experience नहीं है, गाड़ी में interest है.
So, but there is no difference between pulling and pushing horizontally, right?
हाँ, pulling and pushing horizontally, it makes no difference.
Because there is no f sine theta.
Now you have a job to be done here. Kindly tell me what is the minimum force I should apply.
Mu mg
upon minimum denominator should be
Maximum.
for maximum.
Please
You
switch
have
off
to
the chat,
differentiate
sir.
this with
Everyone
respect
is
to theta
chatting.
and equate it to 0. First take this down and solve that. I'll keep you people on mute.
Sir, could you? Sir, the
Sir, can you please turn
Yeah.
off everyone chat? There are some spammers who are sending weird messages. Thank you. Sir, you're on mute.
You want F minimum. For F to be minimum, y equal to cos theta plus mu sin theta should be maximum.
Maximum.
Yes, sir.
dy by d theta should be 0.
Should be 0. Yes.
maximum minimum find करना हाँ sir.
Differentiation of this is minus sin
Sin
theta
theta plus u
mu
cos
cos
theta. U is equals to
tan
tan.
theta is equal to mu. First, I realized that pulling is easier than pushing. At the same angle, if I apply a force, the force which I apply for pulling will be lesser than the force I apply for pushing. Then I decide among the angles, at what angle should I pull to make the force applied minimum? I should apply the force at an angle of tan theta equal to
Mu.
mu. Can you tell me what is that minimum force? F minimum.
Sir, we can
Once
input
I know
mu as
tan
sin
theta,
theta.
you can substitute cos theta, sin
Yes,
theta,
sir.
right?
Yes.
Yes, sir.
Substitute, you will get F minimum.
Done, sir.
Yes, sir.
Find the acceleration of both the blocks. And nobody will shout the answer. Please type in the chat box. You have to find the acceleration of both the blocks. Find the acceleration of the 6 kg block and the 10 kg block. Yeah, you can take G as 10 meter per second square.
Sir, you're on
Unmute.
The hint for the problem is it's a well-laid trap.
Meaning?
It is a well-laid trap. आंखें खोल के दिमाग खोल के क्वेश्चन सॉल्व.
सर इतने सिंपल क्वेश्चन में ट्रैप है क्या?
और ट्रैप भी बहुत सिंपल है.
अच्छा.
Yes, sir.
अगर मुझे ट्रेडिशनली सॉल्व करना है प्रॉब्लम, I will take this T, this T, this T, this will be 2.
Yes, sir.
This will be frictional force, which will be mu n. But listen, assuming friction to be mu n is not a genuine way of solving the problem. Friction can take any value between 0 to mu n.
Yes, sir.
Yes, sir.
So I am assuming mu n and I am solving.
Okay.
I will have first equation as 6g minus 2t 6 7 t minus mu n is 10 8. This is 8. T minus mu is 0.35. Normal force will be mg. 10g is 10 8. This is my first equation. This is my second equation. I have three variables. A2 is equal to 2A1. Solve all the three equations, you will get negative value for the acceleration.
Yes, sir.
Yes.
Yes, sir.
So
And the moment you get negative value, what does that mean? You'll have to reverse the
friction
direction.
is not equal to
ये ऊपर करोगे, this will be going to the left. Will that ever happen?
no.
Do you think friction
No,
will push
sir.
this block to the left? It will not.
No.
This value
No
is
acceleration.
less than mu n. And
No
it will keep
acceleration.
the block at rest.
Yes, sir.
Yes, sir.
Could you tell me what is the value of friction?
Sir,
26 Newton.
equal to the
26.08.
Sir, 26
Newton.
Newton. 6 Newton.
This is क्यों भाई साहब? यहाँ this is
Zero.
60. This is
Mm.
30. If this is 30, what is the maximum value of friction that you are
Sir,
getting?
30 हुआ.
0.35 into 10 into 10. This is 35 Newton is the limiting value of friction. But the tension acting on it is only 30 Newton because this is 60. 2T is 60. P is 30. It's more like telling you there is a block, limiting value of friction is 35 Newton and you're pulling with 30 Newton. Will the block move?
No.
No.
No, sir.
Force acting on it?
13.
30.
30 Newton.
External force acting on it is 30. So frictional force will be 30.
सर तो ऐसे बिना सॉल्व किए पहले चेक कर लेना चाहिए कि मतलब मैक्सिमम भी हो
Exactly.
सकता
First assume things to be in equilibrium and find out the tension. Is this tension greater than the limiting value of friction or not? If it is greater, then the block is sliding. Then start solving the problem. Varna solve hi mat karo. If this tension 30 is lesser than mu n, acceleration of all the three blocks or both the blocks are
Zero.
Zero.
now
The
you
tension is 26
why
Newton.
friction is a smart force.
Yes, sir. Very,
Yes,
very
sir.
smart.
Very smart.
It's not like tension and normal forces.
Yes, sir. Yes, simple.
Things will start becoming a bit tougher in the next class. But next class, I think we have only one more lecture this week.
Yes.
No, sir.
Well, no, we have 2 lectures.
Lectures are there.
Friday,
Then
Saturday.
Friday and Saturday.
Saturday's lecture will be a doubt lecture. I will not take up doubts in the Friday's lecture because there is a huge content which ought to be covered in this category.
Okay.
Yes.
Friday's
Thursday is a
lecture
doubt
will
class?
be a complete regular lecture. Saturday's
Yes.
lecture will be an exclusive doubt lecture.
Yes,
Yes,
sir.
sir.
And sir, after
Sir, your
Friday's lecture
acceleration of both
assignment
the
3, 4.
blocks are 0, right?
After Friday's lecture, you will get the first assignment. If I am able to finish sliding between two blocks on Friday, you will receive the first assignment of Friday.
Sir,
Okay,
your
sir.
acceleration of both the blocks will be 0, right?
Right.
So first we have to assume an equilibrium, right?
In equilibrium, find out if this external force is greater than the frictional force or not. All of you stay, don't run away. There is one important problem I need to discuss. Can I rub the board?
Yes, sir.
Generally, Newton's laws in the last stage, I keep discussing this chain problem, but I forgot in your bag. If there is a chain hanging due to its own mass, this is a chain which is sagging due to its own weight.
Yes, sir.
They'll ask you what are the tensions here. This would be, this is T. This is T cos theta. This is T sin theta. This is T. If this is theta, this is theta. This is D sin theta. Tension will always be tangential to that particular part of the chain.
Yes.
So if you draw the free body diagram here for this part of the chain, I will have T naught here. I will have T sin cos theta here. So this will be 2T sin theta will be equal to weight of the chain.
Yes, sir.
And T cos theta will be equal to T naught. You do the free body diagram of one half of the chain. T naught will be T cos theta. Suppose I draw for this half. T naught will be the same on this side and T cos theta. Suppose I draw for the right half. This would be T naught. This would be T cos theta. Either you draw for the left half or the right half. T cos theta will be equal to T naught is your second equation and this is your first equation. Generally, we ask this question in the MT.
Oh,
Oh, what about the tension acting in the middle parts of the string? Like at every point, we just considered the endpoints.
We considered the endpoint and we calculated the equilibrium condition for that. If he is asking you the tension here, consider this point and calculate. System is in equilibrium.
Yes, sir. So we can just equate those of the endpoints We don't have to consider the middle points.
We don't need to.
What exactly is not here? Like the tension of the middle string.
But the tension keeps varying along the length. At this point, it is T naught equal to T cos theta. Tension is not the same all throughout because the chain has got some mass.
So why is T not equal to T cos theta?
This part of the chain is not accelerating in the horizontal direction.
Yes, sir. Yes, sir.
So this is without friction, right? This is part of NLM.
This is part of NLM. Generally, after covering mass of the rope, I cover this. I forgot in your question.
Okay, okay.
The MT will be tougher than our TWT.
हाँ, MT के बारे में कोई कुछ पूछ रहे थे. सुनो, MT के लिए revision you ought to do it this way. Please go through your class notes once.
Yes, sir.
Class notes से revision करना बहुत जरूरी है. And then in the assignment sheets given to you, those problems which you had doubts, you will go through the ticket.
Yes, sir.
Yes, sir.
Then you will solve 10 problems of kinematics, 10 problems of Newton's laws, 10 problems of errors and measurements, 10 problems of projectile motion from any one of the sources available with you, either Cengage or DC.
Yes, sir.
This is the way you will revise for your MT.
Yes, sir.
Okay, sir.
And when you don't get any question in the examination hall, don't chat with your friends. Directly send me the question. I will know which student is copying.
Yes.
Yes, sir.
Yes, sir.
So in MT in errors and measurements, will we get that dimension problems, that viscosity and all? So we have to remember the formulas. Okay, sir.
Sir, then can you give us
all
a
the
list of those
quantities we need to
formulas
know? Because
that
we're
we need to know?
MT से पहले एक दिन पहले मुझे फोन कर देना. Cost of leaking the paper will be 1,000 rupees per head. सबके सब क्वेश्चंस एक यूनिट्स एंड डायमेंशंस का क्वेश्चन क्यों सभी क्वेश्चंस दे दूं.
अरे थैंक यू सर.
Sir, done, sir, done. 1,000 rupees is nothing, sir. Done.
कैश की पेटीएम.
Sir is doing error
पहले
before
गलती कर रहे हैं
MT.
हम लोग. वो ऑफिशियली पेटीएम पर लूंगा मैं. भी ऑफिशियली करेंगे, अकाउंट में डलवाएंगे.
Sir is doing error before MT fruitful.
You can, but be sure that you're within the limitations of the syllabus. Remind me in the next class. I'll tell you those problems of error which you can attempt, but much of them are already exploited in the class. You will find the questions repetitive.
And sir,
Abhi is class over.
Yes.
And so do we have to practice more of calculus based questions of this NLM?
Actually, they will come into the class once friction is done. We will be dealing with it. So for major tests, we will not stick much to calculus based, but I am yet to see the paper. I didn't see the paper. I don't have an idea. I'll have a word with the paper setter once. In Newton's laws as it is, much of calculus based questions are not possible. जो भी possible है आप लोगों ने assignment में कर. Assignment to those pictures which I sent you people, right? In that, whatever possible.
Yes, sir. Sir, barely 5 to 10 questions.
Sir, even that photo assignment question.
Barely 5
Sir,
questions in the
photo
questions
assignment
we've
question.
solved till now.
Only, actually, calculus based will be minimum. Once friction comes, calculus based will increase.
Okay, sir. Thank you.
Kinematics में calculus based kinematics is huge. उतने सारे आपको Newton's laws में नहीं आएंगे, बहुत कम आएंगे.
Okay, sir. Thank you, sir.
Thank you, sir.
Thank you, sir. Bye.
See you people in the next class.
Thank you, sir.
Thank you, sir. Thank you.
Bye and thank you.
Thank you so much.
Thank